Here we have a system of linear equations. It's a 2 by 2 system, so it has two equations and two unknowns. When you solve a system of linear equations, regardless of how many equations and how many unknowns there are, you want to find values for each of the variables that satisfy all of the equations in the system. So no doubt you've seen these things, and so I'm going to solve this quickly. I'm going to solve it by, what do I want to do? I'll solve this first equation for y. So that would be 3x minus 1. And then I'm going to take this y and plug it into the other equation. So I'll get a single equation just in terms of x. And then I can solve this, distribute. So I get negative x plus 1 equals 0, so x equals 1. And once I have x, and I've already solved for y up here, I can plug this x equals 1 in there. And I get y equals 3 times 1 minus 1 is 3 minus 1 is 2. So I think my solution is x equals 1, y equals 2. And I can check that, which you should always do whenever possible, by plugging into both of the equations. So the first equation says 3 times x, which I think is 1, minus y, which I think is 2, is 3 minus 2. That's equal to 1. So that first equation works. And the second equation says 2 times my x is 1, minus the y is 2, so that's 2 minus 2 is equal to 0. So it works in the first equation, works in the second equation. We have a single beautiful solution, and we're done. So we solved it, we checked it, we know it's right, and it's very good, and it's a very well behaved system because it's just got that one solution. Now you should be aware that these two equations, if you were to think of them in terms of coordinate geometry, if you graphed them, you'd get two lines. So these are two lines that meet one another. So they do something like this, and you have one point where they meet. So if you have a system of two equations and two unknowns, you have two lines. You can have two lines that meet in one spot. You could have two parallel lines that don't meet at all, or you could have two versions of the same line so that they meet everywhere. So this is the situation we have now, where we have a unique solution. If you have two parallel lines, you have no solution. And if you have two versions of the same line, then you have infinitely many solutions. And those are the only three possibilities for solutions to systems of linear equations. So here are a couple more systems that I'll solve very quickly. If you solve this one the same way we solved the first one, so I believe I solved this first equation for y, and you get the same thing, 3x minus 1 here, and then plug this in here, you'd get 3x minus y is 3x minus 1. I'm going to put parentheses around there so I don't forget to distribute. So you'd get 3x minus 3x plus 1 is 0. So you'd get 3x minus 3x is 0 plus 1 is 1 equals 0. Now here's an equation that just is never true. 1 is never equal to 0. And so once you get a contradiction like this, assuming you've done your algebra correctly, you know that the system has no solutions. Because this is never true, and this, in some way, this equation contains information from that system. So when you run into something like this that is never true, you know your system has no solutions. Here, if I do the same thing, solve this equation for y, I'm going to get y equals 3x minus 1. Plug this in here for y, you get 6x minus 2 times 3x minus 1 equals 2. And then I'm going to do the distribution. This is 6x minus 6x plus 2. 6x minus 6x is 0 plus 2 is 2 equals 2. This equation is always true. That means that this system has infinitely many solutions. And if you look back at those systems, I didn't really look at them, I just attacked them. But if you look at these two solutions and you think about them in terms of lines, these two lines are going to be parallel to one another. because they both have the slope 3x, but they're not the same line. So they're, you have this situation where you have two lines that are parallel to one another. If you were to solve this equation for y, you'd get y equals 3x plus 1, which we did. But if you were to solve this equation for y, you'd also get y equals 3x minus 1. And so it's the same line. It's two equations that represent the same line. So we have this situation where every point on this line is also a point on this line. Whereas here, we have none of the points on this line is a point on that line. So those are the three possibilities. When you're solving systems of linear equations, there are three possibilities. You have a unique solution, and in the 2 by 2 case, that's two lines that meet and one point. So you have no solution, parallel lines, and infinitely many solutions. Can't draw a very nice picture of that because one line on top of the other isn't very visually satisfying. And there's just a little bit of terminology I want to give you here. There are consistent systems. That means that you have at least one solution. So this is a consistent system, this is a consistent system, whereas an inconsistent means you have no solution. So this system is inconsistent, these two systems are consistent. So that's a word, that's a vocabulary word that we'll use throughout the semester that you'll need to know. So just a few more systems just to look at. So we're obviously not going to be sticking with 2 by 2 systems. That was 2 by 2 systems were just a way for me to introduce the idea of linear systems, how many possible solutions you can have, and this idea of consistent meaning you have at least one solution and inconsistent meaning you have no solution. But we're going to be dealing with things more that look like this throughout the course of the semester. But I will save that for another video. Okay, very good.